So ringing is caused when you have impedance discontinuities in the path of a signal. How might you have that? How might you have these impedance discontinuities? Well, let's first take an example of the most simplest possible transmission of a digital signal. You just have, so this voltage source represents your signal. There's a certain source impedance. This is just the output impedance of the driver. You have this transmission line, and I'm just drawing it as a single line, but you know it's a transmission line. Then you have a receiver, and this receiver is going to have a high impedance, high Z. Now it's going to have a very high input impedance because it's just a MOSFET. It's just the gate of a MOSFET. So very high input impedance. The source impedance is going to be lower than the transmission line impedance, significantly lower. And if you think about why that has to be, think about it as a voltage divider. You have your voltage, your signal, and you have essentially two impedances. You have the source impedance, that's going to be this CS, and you have the transmission line impedance, Z0. And this is just a voltage divider. If this is large relative to this, then you'll see more of this voltage being dropped across here. And so the actual wave you're launching onto the transmission line will have a lower voltage than you expect, because so much of it is going to be dropped over, so much of the voltage is going to be dropped over this large resistance. So that's why ZS has to be really small. And what that means is it's going to be a impedance discontinuity because it's a different impedance from the transmission line. And then of course the high impedance here is going to be impedance discontinuity because it's going to be much higher than the Z0 of the transmission line. Let's draw the bounce diagram for this situation. And I'm also going to draw off to the side here what the signal looks like that the receiver is going to see. So we launch an incident wave onto here. And I'm just going to indicate this as having this polarity with a plus sign. I don't mean it to be necessarily a positive wave. I'm just saying that I'm just going to define the polarity of the incident wave as like having a plus sign, just to keep track of the polarities of all these waves. So you'll see you'll see a reflected that's not a straight line. You'll see a reflected wave, and this will have the same polarity as the original wave. You have these two waves that are going to be superimposed on each other. You have the incident wave traveling forward and the reflected wave superimposed on the incident wave traveling back. And so let's say that this is the target voltage. Say this is like, I don't know, V signal, and this is going to be time. What you'll see is because of these two superimposed voltages, the original wave, which will nominally have the value of V signal, and then the reflected wave, which is going to have the same polarity, so it's going to add to the original one, you'll actually see initially an overshoot of the signal. Okay, now back to the bounce diagram. You've reached the beginning, you've reached the source again, and now you see this lower impedance. And remember, when you see a step decrease in impedance, what you're seeing, because ZS is going to be lower than Z0, you see a decrease in the impedance, and so the polarity of the reflected wave now is going to be inverted. So now it's going to be negative, and so you start essentially seeing a decrease in the voltage at the receiver, because now this wave is subtracting from what you saw earlier. But this wave will also bounce back. It'll have a reflection, and this reflection is going to also be in this scenario, negative polarity, because again, when you move from Z0 to high Z, is an increase in the impedance, which means you keep the same polarity. And so you have this negative reflected wave backwards. And so now you're going to undershoot. You're going to go lower than what you want. And this just keeps happening. This will keep sort of repeating. And this is, eventually it'll stabilize. But this is the phenomenon of ringing. You see these overshoots and undershoots, and it's essentially, ultimately, it's caused by the impedance discontinuities at the source and the receiver.